Okay, this is section 5 of chapter 2. The first thing we want to do is do a little review of the distributive property. I'm sure all of you are pretty aware of this, but I want to review a few things and take another look at it. First of all, we have 5 times the quantity, that's the way you read this, 5 times the quantity x plus 7. And what we need to do in this situation is we need to distribute the 5 over both terms inside the parentheses. So 5 times x would be 5x. 5 times a positive 7 would be a positive 35. Okay? Now there's another way to look at this, and I want you to learn to do this if you haven't done so already in the past. Look at this as an area model. So if we were looking at the area of this piece of it and the area of this piece of it, well, the area is the length times the width. Well, one of these terms is x, so in other words, we're multiplying 5 times the quantity x plus 7 up here, and we're breaking it into 2 different pieces. So we're going to multiply 5 times x, we get 5x for that area. Multiply 5 times 7, we get 35 for that area. And of course we should see this as a positive 35. So again, we end up with the same answer we had before, 5x plus 35. Okay? So there's your review. Now let's start with example 1 in the book. The problem states 15 times the quantity 20 plus d equals 420. First thing we need to do is distribute this. I drew a little area model in here quick. I want you to use that if you need to, but the sooner you get away from that, the quicker things will move. So we have 15 times the quantity 20 plus d, the 15 times 20. Well, that'd be like 15 times 2, which is 30. Add the 0 back, we can do it in our head. That's 300. And 15 times d is obviously 15d. And since both signs are positive, it is a plus. So we have 300 plus 15d equals 420. And now it's just a matter of solving this problem the way you've been doing all the other problems you've been doing. In order to undo addition of 300 on this side, we will subtract that 300 from both sides of the equation. These become what I want you to start looking at as a zero pair. This does. So we have 15d equals 420 minus 300, which is 120. Next step of the equation is to divide both sides by 15, and I get d equals 120 divided by 15 is 8, and I have a solution. Please press pause and do problems A and B. One more thing I want to review quick. On page 154 there is a key concept. Whenever we have these key concepts in the book, I want to remind you that those are things that ought to definitely be on your gold sheet. Put them in your notes. Okay, so let's review what that says real quick. Whenever we solve an equation and we end up with no solution, it will look like this, where you get 8 equals 15, or some other statement like that where the left side does not equal the right side. So we would change it to a not equal sign, and we call that the null set, or we call that no solution, or in some cases people even write the empty set like this. Any of those answers would be acceptable. Sometimes we will solve an equation like the last one we just did, where it comes out to be d equals 8. In that situation we have one solution. Okay? And then lastly, sometimes we solve an equation and we end up with a statement like this: 8x plus 22 equals 8x plus 22. Now we could subtract 8x from both sides and end up with 22 equals 22. We could even subtract 22 from both sides and end up with 0 equals 0. But I'm expecting that once it gets to the point where this is exactly the same as this, you see this as an identity. This is the same as this, it's an identity, and in that case we talk about infinite solutions, or most likely what you're going to put for your answer in these situations is all numbers. Now let's move on to example number 2. Example 2. We have 6 times the quantity x minus 3 plus 10 equals 2 times the quantity 3x minus 4. First thing we need to do is distribute here and distribute here. This is an easy process. Once you do a few of these, you should get pretty good at it. 6 times x is 6x. 6 times negative 3 is negative 18, or subtract 18, however you want to look at that. Plus 10, carry it down, equals 2 times 3x is 6x. 2 times negative 4 is negative 8. So we have 6x minus 8 on this side, and 6x minus 18 plus 10 on this side. Well, the first thing we want to do is combine these two like terms, Negative 18 and positive 10, they're both constants. We want to combine those. We get 6x minus 8. And we already had 6x minus 8 on this side, so we're done. Again, we could subtract the 6x from both sides. It's unnecessary. We should see that right away as an identity, and our answer is all numbers. Example number 3. We have 8 times the quantity 4 minus 2x equals 4 times the quantity 3 minus 5x plus 4x. First thing we want to do is distribute each of these pieces. 8 times 4 is 32, minus 2x times 8 is 16x, so it's a negative 16x. 4 times 3 is 12. 4 times negative 5x is negative 20x. And then don't forget your third term there, add the 4x. And now once again we're going to combine like terms. In this case it's not constants that we can combine, we're going to combine the x's. We have a negative 20x and a positive 4x. That clearly is a negative 16x, so we have 12 minus 16x on this side. We have 32 minus 16x on this side. Now some of you will see right away that this is the same and this is not, and you probably will sense something here, but let's go through the procedure. We have to add 16x to both sides to undo the subtracting here. Do the same thing over here. These both zero out, and we end up with 32 equals 12. And of course that is not a true statement, so we change it to not equals, and we either answer null set or no solution. This is the one that you're probably going to see in the back of your book, or empty set. It's all the same answer. Please press pause and do letters C through D. Now let's see how this works when we use this in a real life situation. So here's your problem. You're given where we buy 3 snacks, 10 ride tickets. The ride tickets cost $1.50 less than the snacks cost, and we spent a total of $24. So the question is, how much is the cost of a snack? So right away we recognize we want to let S represent the cost of a snack, and then we write an equation. Well, since we bought 3 snacks, we would write the algebraic phrase 3S, which is 3 times the cost of the snacks plus 10 times the cost of the ride tickets, and the ride tickets cost $1.50 less than snacks. So remember, this has nothing to do with a less than symbol. This is $1.50 less than the cost of the snacks. And we have 10 times that, but because we're doing a subtraction here, we have to put that in parentheses, find out what that number is, and then multiply it by 10. Or in this case, we're going to distribute it. And then lastly, of course, we spent $24. So our equation is 3S plus 10 times the quantity, S minus the $1.50, will give us our $24 that we spent. So our equation, 3S plus 10 times the quantity, S minus $1.50, equals $24. First thing we want to do is distribute this. We get 3S plus 10 times S is 10S minus $1.50 times 10 is 15, so minus 15, and we have $24 over here. We want to combine these two like terms. We get 13S. Next step, we can undo the subtraction of 15 by adding 15 to both sides. We have 13S equals 24 plus 15, which is 39. Divide both sides by 13, and we have S, our variable, equals 3. Now we need to put it in a statement, nice short easy statement. Snacks cost $3 each. Thank you.